Hello students, today we will start with chapter 9 application of trigonometry. This chapter is relates with the use of trigonometry in our daily life. So we have learned so many things in our previous videos for trigonometry. Now after learning those things you may be thinking what is the use of it. So what is the use of it? You can see through these questions. So from question number 1 we are starting, and you will see that these questions we cannot solve in geometry or algebra or Pythagoras theorem. That's why trigonometry is necessary for our daily life. Daily use also it is important. So question number 1 we are starting. One diagram is given. This is one diagram is given. ABC, A, B and C, and it is 20 meter, and here it is 30 degree. Of one thing in our previous video I told कि for 30 degree angles you make a figure like this. Here you make 30, it is 30. Then you write it under root 3, 2 and 1. So your ratio will be like this. And suppose it is 60 degree. Then what you will do? You will make it like this and write 1, 2 and under root 3. Your ratio will be like this. In 30 degree, it is 60, then it becomes 30. So 30 degree, it becomes base. So that's why base it has come, and it becomes perpendicular. So for 30 degree, you remember always under root 3, 2 and 1. Because highest is always hypotenuse. So 2 will always remain here. Under root 3, 2 and 1. And for 60 degree, you remain 1, 2, 3. And for 45 degree, you remember 1, 1 and under root 2. These three diagrams you remember. Wherever is needed for 30 degree calculation, 60 degree or 45 degree, you make ratio from here. You make ratios from here. Okay, ratios. Or you can learn also. Better you learn all the ratios. You learn, that will be more better. But if sometime you forget any ratio in the exam or you are confused, then with the help of these three diagrams you can find any ratio. So here in the question is, this is 20 meter long rope which is tightly stretched and tied from the top of a vertical pole of a ground. This is the pole. It is a pole. It is pole and it is rope. Okay, rope. Find the height of the pole if the angle made by the rope with the ground level is 30. So here you see only two figures are given, 30 degree and this. So Pythagoras you cannot use, algebra you cannot use, or in geometry also you cannot find out. So easiest way is trigonometry. So in this easiest way, how we can find it? So we have to find the pole. We know one relation. This is the one relation. Okay, that is sine. So here we will go with that and find the value of this. So here sine 30 we are taking. Sine 30 degree. Sine 30 degree is equal to AB upon AC. 30 sine 30. Suppose sine 30 will be, what will be 2 upon 1. It will be, sine 30 will be your sine 30. Sine 30 will be 1 by 2. From here to this, sorry. Sine, it is pole to this side. Pole to this side. So pole to this side it will be 1 upon 2. Sine 30 will be 1 by 2. Or AB is not known and AC is 20 meter. So what we can do? This 20 we can transpose to this side. So 20 upon 2 is equal to AB. So AB is equal to 10 meter. And this is your answer. Means pole AB height will be 10. Now we will go to the next question. Okay. A tree break due to the storm and broken part bent so that the top of the tree touches the ground, making an angle of 30 with it. So what is the position? I will draw a figure here. I will rub it and draw a figure. Okay. So this was one tree. Tree was up to this tree was a high tree was there. Due to storm, it was broken, and from a from somewhere from the trunk, it broken and fall to the ground. This is ground. Okay, ground, and fall in the ground, making an angle of 30 degree, making a angle of 30 degree. The distance between the foot of the tree, this is foot of the tree, foot of the tree, foot of the tree to the place where the top touches the ground. Top is broken and touches the ground here. From this P point to here, it is 8 में. So what is the height? So for this case also, we will find the first we will find the tree height. Okay, and tree height will be how much? Tree height is this much plus this much, because this portion is broken and fall down. So this and this. So we will find for this also and this also. Two times we will solve, and we will add both, and height of the tree will come. Okay, so we were going to solve it. First we have made the strategy, now we are going to solve the question. So height of tree, height will be equal to AB and plus AC. We have to solve these things. Okay. So in triangle ABC, one triangle only there. So 10, first we will take 10, 30, 10, 10, 30. 10, 30 degree, 10, 30 degree will be AB upon BC. Okay, AB upon BC. So here for 10, 30, our formula is 3 to 1. So our relation is 1:3. 1:3. So 1 by 3, it will become 1 by under root 3. And this side, AB will remain as it is, and here 8 will come. Now we will transpose it. So 8 upon under root 3 will be AB. So AB is solved. Now we will find this height, this. So for this, we can find cos from here to this side. So we will find cos 30. Cos 30 degree. Cos 30 degree equal to BC. BC upon AC. So cos 30 will be how much? Cos 30 will be 3 under root 2. From here to here, 3 under root 3 to 2. Under root 3 to 2. If you learn all the ratios, it is very easy. Otherwise, just you draw 3. Just you draw these 3 for you, and it will be easier for you. Okay, it will be very easy for you. This is 45. This 3 is helpful. So BC is 8. And AC is not known. So AC will go to this side. So 3 under root AC. It will go to here, and in multiply situation it will come. Equal to 8 into 2. So is equal to 16. So to solve, because we have to solve AC also. AB we have solved, AC we have to solve. So AC we will take to one side. So AC will come here, this side. So what will happen? If AC comes this side, this figure will to other side, and it will go to the downside. So 8 upon 3 upon 2 it will become. Now it is in divide position, so we can reverse it. Multiply and 2 upon 3 we can write. Now it is 16 upon 3 it will become. Now AC, AB and height we can find out. Height is equal to AB we have calculated AB 8 upon under root 3. And AC is 16 upon under root 3. Okay, height is equal to this one. Height is equal to AB plus AC. Okay, so here LCM is 3. So LCM 3 will remain. 8 and 16 will add. So 8 is 8 and 16, 24. And this 3, 24, we can make a bifurcation. 8 into under root 3 under root 3. Because this total will be multiplied, total will be 3. So 8 3s are 24, 24 into 3, and this 3 we can break in two parts, under root 3, under root 3. So under root 3 is here, this we can cut. So your height will be 8 under root 3, and this will be your answer. Okay, this is your answer. Now we will go to question number 3rd. Okay. A contractor plans to install two slides, slide 1 and slide 2. He wants to slide for the children to play in a park. For children below 5 years of age, she prefers to have a slide whose top is at a height of 1.5 meter. It is the top of the slide here, top of slide, top is at 1.5 meter. Okay, this is 1.5 meter. And is inclined at an angle of 30 degree to the ground, and this top is inclined to the ground. This is your ground, it is or for 30 degree, it is inclined and to the ground. Whereas the elder children, she wants to have a steep slide at a height of 3 meter. Here she wants a height at a height of 3 meter. So this is the top, and she wants a height of 3 meter. Okay, slide and inclined at an angle of 60 degree to the ground. Its top is inclined to the ground at 60 degree angle. What should be the length of the slide? Slide's length means your this hypotenuse you have to find out. Okay, better. So here we can go with the relation from this to this, from perpendicular to slide. So sin 30 degree and sin 60 degree we will find out. Okay, and both the, so for question number 1 we will find out first. For question number this part 1, first slide we will find sin your 30 degree. Sin 30 degree. So sin 30 degree will be AB upon AC. AB upon AC. And AB is given 1.5 meter. AC is, you have to find out. And for 30 degree, you see our relation is, what will be the relation? 2 upon 1. So 1 upon 2. Our relation is from perpendicular to hypotenuse. This sine. So sine we will find by perpendicular to hypotenuse. This is perpendicular. This is your base and this is your hypotenuse. Perpendicular to hypotenuse. So sine 30 will be 1 upon 2. 1 upon 2. So what will happen? We will bring AC to this side and this to that side. AC is equal to 2 into 1.5 meter is equal to 3 meter. This is the answer. For this, for slide 1, 3 meter is the answer. For second one, sin 60 degree we will find out. Here sin 60 degree will be your sin 60 degree will be PR upon PQ. Sin 60 will be your under root 3 to 2. Under root 3 to 2. This we are, either you remember it or from the diagram we are under root 3 to 2. We are getting PR is 3 meter upon PQ. So for finding PQ, we will take this figure to here. So PQ is 3, or this figure will come down. Under round 3 upon 2 is equal to 3 into 2 upon under root 3 is equal to 6 upon is equal to, what we can do? 3 we can break. 3 under root into under root 3 into 2 upon under root 3. So this one we can cut. So equal to, it will become, 2 is whole figure, so it comes first 2 under root 3 meter. So this will be the height of the second one. Okay, this will be your answer. Okay. Now we will go to question number 4. Okay. So here one building height, it is one building is there. One building is there. So what the angle of elevation of the top of a tower. Okay, it is a tower. Top of a tower. From it is top. So top of the tower from a point on the ground. This is the ground on point which is 30 meter away from the foot of the tower. This is foot of the tower. This is foot of the tower. This is top of the tower, and it is your tower. Okay. Foot of the tower, this is from the foot of tower, it is 30 meter, and top is making an angle of 30 degree. Find the height of the tower. Okay, so here what we can find, we find tan we can find, so AB will be answer. So in we will find height is equal to height, your height will be AB tan 30 degree. It will be tan 30 degree, and tan 30 is equal to AB upon BC. And tan 30, we have told there, tan 30 is 1 upon 3. So what we can write? We will write 1 upon under root 3. Tan 30, AB we can write, AB is not there, AB we have to find. And it is 30 meter. So this we will take to this side and this to this side. Or AB will let it remain, AB will come to this side. 1 minute. So AB will come to this side, it will become AB into under root 3 is equal to 30. This one will come this side. Okay. So AB will be 30 upon under root 3. This 30 we can write into 10 into 3 upon under root 3, or we can write 10 into under root 3 into under root 3. We can break it. So 1 under root 3 will go out. What will remain? 10 under root 3. This is answer here. Okay. This will be your answer. So now we will go to question number 5. Question number 5. In the question number 5, a kite is flying at a height of 60 meter. It is above the ground. The string attached to the kite is temporarily tied to a point to the ground. Here it is tight. Kite is tight. The inclination of the string with the ground is 60 degree. It is inclined at a position of 60 degree. Okay. Find the length of the string. We have to find it. Okay. So it will be equal to your tan is available. So it will be your sine 60 degree. So string length. String will be equal to sine 60 degree is equal to sine 60 degree is equal to AB upon AC. Okay. So sine 60 is under root sine is 60 is your 1, 2 under root 3. So it will be 3 by 2. So sine 60 is 3 by 2. And AB is your 60, and AC you have to find out. Okay, now again AC will go to this side and it will go to this side. 60 into 3 upon under root 3. This will come to this side. Okay, here it is in multiply, here it will come. So this under root 3. So it will go, it is downside, it will go up. So it will be 2 by 3. So again it will be 120 or 60 we can break. 60 we can break as a 3 into 20 into 2 upon under root 3. This 3 we will break, under root 3 into 20 into 2. So this will go out. What will remain? 3 and 40 will remain. So it is the whole number, it will come first. And it will go down. This is the AC. AC is the string equal to 40 under root 3 meter. This is your answer. Okay, question 5 is now over. We will go to question number 6. Question number 6. 1.5 meter. This boy is off 1 point. This is your B point. 1.5 meter. 1.5 meter boy is standing, tall boy is standing at some distance from a 30 meter tall building. This is your building, 30 meter tall building. It is a building, and building height is your 30 meter, means A to ground. This is your ground. So 30 meter height is from the ground level, but person is, he is here on the ground, and from here his eyes are here. From here he is looking to the string, the angle of elevation. From here he is looking to upward side elevation. From his eyes to the top of the building increases from 30 to 60, means previously his eyes was at a 30-degree inclination. Now it increased to 60 degree. This person is walking to this side. He is walking to this side, towards the increases from 30 degrees to 60 degrees as he walks towards the building. He is going to the building. This is the building. He is walking to the building. It is increases. Find the length of the, find the distance he walked. You have to, previously he was here, came up to here, and from here if he looks it becomes 60 degrees. Now they want to know the distance he walked towards the building, how much he has walked to the building. Okay, so for this we will first in this triangle we will go. Okay, or this we can take A, B, D. First we will find this full length we will find. So in triangle A, B and D, this it will be tan. So tan 30 will be AD upon BD. Tan 30 is 1 under root 3. Tan 30 is your 1 under root 3. Okay, and AD will be how much? Building's height is 30 meter. This is of the building. Building height is 30. And boy is of 1.5. His eyes are here. So what will be the height? Height will be 28.5 meter. AD will be 28.5. 28.5. AD is 30 meter minus 1.5 meter. Okay, it will be 30 meter minus 1.5. So AD upon BD, upon B and D. Okay, so upon B and D. BD we have find out. So BD will come to this side, 28.5, and this will go this side and it will become under root 3 upon 1. So BD is equal to 28.5 under root 3. So full length is BD is this much. Now we will find tan 60. Okay, this portion we will find, and from the total from BD we will reduce the CD, so it will come out how much he has worked. Okay, so from this angle, from this point where he has reached, we are now, okay, this is ACT. So in triangle ACT, tan 60 degree is equal to tan 60 80 upon CD. Tan 60 will be under root 3 by 1, so it will be tan 60 will be under root 3 and AB in triangle ACD, AC upon CD, it will be AD upon CD. So AD is 28.5 and CD will remain. So CD will be, it will go to this side and CD will come to this side, 28 upon 5 under root 3. So CD we have find out and full length. So now we will find out the distance walked, BD minus CD. So distance walked is equal to full length from this side up to the building, full minus whatever we have got, CD minus CD, figure is well. So BD figure is 28.5 under root 3 minus 20, CD is 28.5 and under root 3. Okay. Now here our, I will rub, and from here I will do again. Start. So here we will take, here nothing is there, 1 is there. We will take a plus and minus of fraction is done by LCM. We will take an LCM. So distance will be equal to LCM. LCM is under root 3. This is your LCM. So 1 will divide it and under root 3 will be the answer. Under root whatever will be the answer, we will multiply it. So first figure will be 28.5 under root 3 will be multiplied by the answer. Answer will come this. So we will multiply this. Then this side, it will also divide here. 1 will come and 1 will multiply 28.5. It will remain 28.5. So what will happen? This 28.5, here multiply sign is understood. 3 and 3 under root, it will become 3 minus 28.5 upon under root 3. Okay, so here it will multiply. So here it will multiply and it will become 85.5 minus 28.5 upon under root 3. Okay, now we will subtract. So 0, 8, 7, 15, 57 upon under root 3. It is 19 into 3. Why 3 we are taking? We have to see how it can be solved. So we have tried to find out 3. We have divided this figure with 3 and 19 has come. So we guessed. Then this under root 3 is here. This 3 we can make it like this. 19 into under root 3 into under root 3. Okay. Under root 3 is there. So this will go out. What will remain? 19 under root 3. So distance walks will be 19 under root 3. This will be your answer. Okay. So this is your answer. This question 6 is over. Now we will do question number 7. Here question number 7. a point on the ground, a point on the ground, a point on the ground, the angle of elevation of the bottom, angle of elevation of the bottom, angle of elevation of the bottom and top of first bottom then top, bottom and top of transmission tower. Here is one tower, a transmission tower is fixed on the top of a building. So bottom is 20 meter high. This building is of 20 meter. 20 meter. Okay, so this is 20 meter here. Okay, 20 meter is here. It is 20 m of building, 20 meter building. Okay, building. Are 45 and 60 degree respectively. It means bottom is 45, from bottom 45 and top 60 degree, because this respectively will one first and second one is for second. So this is the position. We have to find out the height of the tower. This tower's height we have to find out. What is the height of the tower? Tower height we have to find out. So we will start with 10, because this side 10 to the base we will start. Okay, then full we will find out. Okay, so first we will find out 10 in angle ABC. We will mark it as a D, ABCD. So in triangle it is BDC, BCD, BCD. Tan 45 degree, tan 45 degree is DC, DC upon BC. Okay, so tan 45 is equal to 1, tan 45 comes to 1, and DC is 20 meter and BC is here. So BC will come to this side and it will become 20. So this ground is of 20. BC is 20. Now we will find out in triangle ABC. So in triangle ABC, tan now 60 degree it is, tan 60 degree is equal to AC upon B and C. Okay, so tan 60 degree is under root 3. Tan 60 degree is under root 3, and AC we have to find out, and BC is 20. Okay, BC is 20. So here AC will be 20 into under root 3. Okay, so it will be 23 is equal to AC. Now we will find out the height of the building. Height of tower is full AC minus DC. Okay, AC you have find out 20 under root 3 minus DC you have calculated, and DC is given 20. So how we can minus? If such type of situation arises, you take the common out. Okay, so common 20 we will take out. What will remain here? Under root 3. What will remain here? 1 will remain here. So this will meter. So this will be your answer. So height of the tower is this one. Okay, by this hour, this 7th question is over. Thanks for watching our video. It is being too much lengthy, that's why we will make another second video for the rest of the questions. Thanks for watching. Please share with your friends so that they can also subscribe and they can also get the benefit of this free tuition. Thank you for watching.